Okay, so let's talk about joint variation. Joint variation. Okay, so a relationship can exist between more than two variables. The first two relationships we looked at, inverse and direct, were simply looking at a relationship between two variables. But a relationship can exist between more than two variables, right? So, for example, your mark in an exam, right, can be affected by your knowledge, the difficulty of the exam, maybe your concentration levels, how much sleep you got the night before. So these are many different things that can affect your mark in an exam. So joint variation serves that purpose. It serves the purpose of showing a relationship between many variables, right? So the joint variation is simply a combination of two or more direct variations or inverse variations. So let's look at an example there, right? Example is A varies directly as B and C. A is equal to 30 when B is equal to 2 and C is equal to 3. A, find the relationship between A, B, and C. B, find A when B is equal to 4 and C is equal to 5. Okay, so now let's write that. We know that A in this case varies directly as B and also varies directly as C. So you write both, right? A varies directly as B and C, right? And then from here, you just follow the familiar procedure. We remove this, put an equal sign and a constant. You get A is equal to KBC. From here, we want to find our actual value of our constant K. So we need to plug in values for A, B, and C, right? Which is 30, 2, and 3, right? So 30 is equal to K times 2 times 3, right? So 30 is equal to K, 2 times 3 is 6. To find the value of K, we divide both sides by 6. We'll get 5 is equal to K, right? So once we've done that, we can take this up here. We substitute the value of K here and get A is equal to 5BC, right? So that's the relationship. That's the relationship. Okay, A is equal to 5BC. That's the relationship there. Now we know that once you found the relationship, you can use it to solve the other problems. So find A when B is 4 and C is 5. So B is 4, C is 5. We substitute there. A will be equal to 5 times 4 times 5. And what's 5 times 4 times 5? That's 100. So there it is. Solved. Okay? So now let's try another example. R varies directly as T and inversely as the square root of S, right? R is equal to 10 when t is equal to 12 and s is equal to 9. A, find the relationship between RT and S. B, find R when T is equal to 6 and S is equal to 4. Right, so now let's solve that. So find the relationship between RT and S. So we're told, let's follow this. R varies directly as T. So the relationship between R and T is direct. But then the relationship between R and S is inverse. So we need to show that. So R varies directly as T, but inversely as the square root. Inversely as the square root of S. So this is how we write it. R varies directly as T, but inversely as the square root of S. So R is equal to KT over square root of S, right? So I simply substitute my values of R, T, and S to find my K, because that's what I need to do here. So 10, 12, and 9. So 10 is equal to K times 12 over square root of 9. Square root of 9 is 3, so if I bring it up here, 10 is equal to K times 12 over 3. 3 into 12, that's 4. So 10 is equal to K times 4, right? Divide both sides by 4. I'll get, that's K is equal to 5 over 2. Okay? Once I know K is 5 over 2, I can rewrite that and say R is equal to 5T over 2 times square root of S. Pardon me. So it's 5T over 2 times square root of S. So then we take that, right? R is equal to 5T over 2 times square root of S. R is equal to 5T over 2 times square root of S. Oh, S there. Okay, so now we're asked to find the value of R when T is 6, S is 4. So T is 6 and S is 4. So R is equal to 5 times 6 over 2 times square root of 4. So R is equal to 5 times 6, 30. Square root of 4 is 2. So it will be 2 times 2. R is equal to 30 over 4. So the final answer is R is equal to, that's 7.5 there, or 7.5, whichever one you prefer. So you can try some questions on inverse variation.